Okay, so last time we talked about simplifying surds, and so today we're just going to talk briefly about rationalising. This is nothing new, but it's something that we need to understand thoroughly. So a quick definition or a reminder of the definition: a rational number is a number that can be written as a fraction. So it's any number that can be written as a over b, where a and b are both integers, where they're both whole numbers. And your classic examples of rational numbers are pi, and then integer square roots that we don't know. So, for example, I know the square root of 4 is 2, but the square root of 2, 3, and 5, I don't know, and they are irrational numbers. And specifically, when we're talking about rationalising, we're talking about fractions that involve surds and getting rid of the irrational denominator. And this is because manipulating denominators is really important in fraction arithmetic, and we want to have no surds, no irrational numbers there. So hopefully you remember the technique. These first three, I multiply by root 3, top and bottom. And the key fact is that the square root of 3 times the square root of 3 is the square root of 9, which is 3. So I get 2 root 3 over 3. Here, I'm going to multiply top and bottom by root 15. So on the bottom, I get 15. And on the top, we use the reverse of the rule we use when simplifying surds. So this is the square root of 45. 3 times 15 is 45. Now, okay, could leave it like that, but I wonder if this can be simplified. And it can, because I can write the square root of 45 as a square root that I know multiplied by a square root that I don't know. So it's 3 root 5. And then I can just cancel it like a fraction. Both of these are in the 3 times table. So I end up with 1 root 5, which I hope you don't mind me just writing as root 5, over 5. Don't leap to multiply by this straight away. So with this one, this can be simplified. So I'm going to leave the root 5 on top, but root 80, that's one of the ones we did last time. If you remember, that's root 16 times root 5. And I know that root 16 is 4. And I can just cancel those out. What I'm doing there is dividing the top and the bottom by root 5. So remember, I'm left with a 1 on the top. I'm not left with nothing on top. I've divided by root 5 by root 5, so I get 1. Okay, I'm going to give you an exercise for all this in a minute. So let's move on to slightly more complicated expressions, and you again will be familiar with these, I'm sure. So here we don't multiply by root 3, we multiply by 1 minus root 3, top and bottom. So on the top I've got 1 times that, so that's 1 times 1 and 1 times minus root 3. On the bottom, I've got to grid that out. I've got to multiply that out. So just pause at this point and multiply that out and see what you get. Okay, so I've multiplied this out over here, and this is a key result. So root 3 times root 3 is 3, but if it's a positive and a negative, mixture makes a minus, so you get minus 3. So if I combine those, I call that peanutting. I've got 1, take away 3, so that's minus 2. And the good news is that, and that's why we do this pattern, is the surds cancel out, because you've got a plus root 3 and a minus root 3. Now, sometimes you can simplify this. I would suggest in this case it's best left like that. But I have got 2 things divided by 1 thing, so I could choose to split that into 2 separate fractions. And this 1 over minus 2, we would probably just write it as minus a half. That minus sign, I can leave it there. I could put it here, or I could put it in front. It doesn't really matter. But look, I've got minus root 3 divided by minus 2, and that's going to be plus root 3 over 2. Now, I say again, nothing with leaving it like that. I think I probably would in that case, but that is the same thing. That's 2 ways of writing the same answer. Okay, so with this one here, I'm going to multiply by root 8 plus root 7. And that's a bit more complicated both on the top and on the bottom. So again, pause, see if you can multiply out the top and multiply out the bottom. I'm running out of space, so I'm going to do mine on a separate bit of paper. Okay, so if I look at the numerator, that's a single bracket expansion. This is a single term, 5 root 2, so I'm just multiplying both of those things by 5 root 2. I don't normally use a grid for that, but I think it's probably worth doing here. So 5 root 2 times root 8, well, root 2 times root 8 is root 16, so you get 5 root 16. But I know the square root of 16 is 4, so you end up with 5 times 4, that's 20. 5 root 2 times root 7 becomes 5 root 14. 2 times 7 is 14, so that is as simple as that. So my numerator is going to become 20 plus 5 root 14. If I look at the denominator, I've gridded that out. Those cancel out, and look what happens when I peanut here. I've got root 8 times root 8, which is plus 8, and minus root 7 times plus root 7, which is minus 7, so you end up with 1. And that's just that. Okay, third example. We're being asked to rationalise this expression. So before I can do anything, I need to multiply out the denominator. So this isn't rationalising, I haven't got to that stage yet. I've just multiplied out that denominator. So the numerator is just 1. If I have a look what I've got, so I've done 3 minus root 2 times 3 minus root 2. So I've got a 9, and root 2 times root 2 is 2, and 2 minuses mean that's positive. So that's giving me 9 plus 2, so that's 11. And here I've got minus 3 root 2 and minus 3 root 2, so that's minus 6 root 2. Now I haven't rationalised yet, all I've done is expanded that denominator. So now I am going to rationalise, and I'm going to multiply by 11 plus 6 root 2. The numerator is nice and easy, it's just one lot of that, so that's what I'd like you to do last time is pause the video and expand that and see what you get as your denominator. Okay, I don't underestimate how fiddly this is actually, multiplying out this denominator. So 11 times 11, that's 121. I'm going to be lazy, and I already know that those two are going to cancel out, so I'm not even going to bother working them out. So what I've got here is 6 root 2, sorry, minus 6 root 2 times 6 root 2. Well, as a little aside, if I do 6x times 6x, I do 6 times 6, which is 36, and x times x, which is x squared. If I've got 6 root 2 times 6 root 2, I do the same. 6 times 6 is 36, and root 2 times root 2 is 2, which gives me 72. If one of those two 6 root 2's is negative, then the answer will be negative, so I end up with minus 72. And does that give me 49? I think that gives me 49 as my denominator. So I want you to find the practice for rationalising surds in the online textbook that I've just granted you access to. So you've had either an email or a message on class charts, which hopefully will allow you to get to this point. And you've been given access to 2 books, the Pure book and the Statistics and Mechanics book. We might get into a bit of statistics or mechanics if the closure continues. But we're looking at Pure at the moment, so let's open up that Pure book. And it, I'd love to say this works really well on phones. I don't really think it does. I mean, it does work on phones, but I really think it only works really well on a bigger screen. Having said that, plenty of people in Year 12 and Year 13 have used their phone with it. So I am going to go next page, and we are working through Chapter 1, Algebraic Expressions, and we'll actually find practice that I want on page 14. So down at the bottom right here, I'm going straight to page 14, and it's exercise 1F up here on the right, and we've already done a few of these questions in my work examples earlier in the video, and I certainly wouldn't expect you to complete all of this, but I think it is worth doing questions from every question, 1, 2, 3, and definitely having a go at question 4, because question 4 is really how it looks in the exam. The good thing about the online textbook is that there are answers at the back, but also every exercise has a solution bank. If I click on this page icon here, I can open up worked solutions for that exercise. Now we're at A level now. The idea is not just for you to copy these into your book and therefore feel like you've done the work. The idea is that you have a go and that these are there for you to check your answers and also to troubleshoot the things you got stuck with. That doesn't mean I don't want to hear about the problems you're having. I'm very happy to help you as well. But can I encourage you to spend a bit of time working through that exercise 1F on page 15, and we'll have a chat about question 4 on Monday. For those of you keen to sort of push yourselves on, mixed exercise 1, we're clearly at the end of chapter 1. Mixed exercise 1 is a sort of collection of questions. The mixed exercises at the end of each chapter tend to get a little bit trickier. So although I'm hoping the first few are things you could do with your GCSE knowledge, there are definitely some trickier questions later on, and next week I'm going to encourage you to sort of delve into those, and I'm going to help you through some of them. I think the key thing with A-level is not being frightened by scary looking questions. Instead, working out what it is you've got to do, and it's that sort of journey which we will be going on over the next 2 years. Anyway, so you're going to work through exercise 1F, not all of it, be sensible about the ones you choose, but that would be my recommendation for today's work, and I will post another video on Monday.